Hi, I'm Dr. J. Varma, and welcome to Thermometer. On this channel, I check the temperature of health in the United States and around the world and give you expert insights on public health and infectious diseases. And I'm pleased today to welcome my friend and colleague, Dr. Jon Epstein, for a weekly episode called Inside Bird Flu, where we discuss the latest news about the H5N1 influenza epidemic occurring here in the United States and in other countries. Thanks, Jon, for joining me.
Hi, Jay. Thanks for having me today.
Yeah, it's great to have you. You know, it's interesting. I've been thinking a little bit more about viruses lately because I woke up today totally
Wait, it's
achy.
possible for you to think even more about viruses?
Shockingly, yes. Like I woke up today and I was all achy all over. And the reason is not because,
Mm.
thankfully, because I have a new disease, but I got the second dose of the shingles vaccine.
Yep.
And that obviously reveals my age, that I'm of the age over 50, that you recommended to get the shingles vaccine. But I don't know if you know about this, Jon, but I didn't really necessarily get it because I was worried too much about shingles. I was worried about something else completely differently.
What else is there? I mean, I got the vaccine as well because I know about the risk as you get older to getting this really, painful recurrence that is shingles. But what else is there that the vaccine protects against?
Yeah, so there's an emerging body of data showing that one of the many ways in which we get dementia as we get old, things like Alzheimer's, where we lose our memory and other brain functioning, is an inflammatory process. And there's a lot of good data showing that one of the ways in which that inflammation kicks off is when we're exposed to common viruses that are out there. And one of the most common viruses is the chickenpox virus called varicella zoster. And as we get older, that virus lays dormant in our nerves and then reactivates and causes this painful rash that we call shingles. So the vaccine was originally developed to prevent this painful rash from occurring later on in life, which can also be associated with nerve problems and chronic pain. But it turns out there have now been some very large studies showing that it may also protect against dementia.
Yeah, Jay, this is incredible. And it really, when I hear this, it reminds me that we are learning a lot about chronic disease and how there may be relationships between infectious diseases that happen earlier in life. And it's a real important area of study. There aren't that many research groups that really dig into this, but there are groups studying things like chronic fatigue syndrome and perhaps the relationship between early viral infection and that chronic disease. So we used to think of these things as totally isolated, but in fact, we're learning there's more connections to what we think of as non-infectious diseases and infectious diseases.
Yeah, and so we won't go into in too much detail on this, but there have been some very good large studies using real-world data from the United States. Another study came out last week looking at data from Wales and England, and they compare people who are very, very similar and they adjust for their differences, showing, pretty large 15 to 20% reduction in the incidence of dementia. And again, as you just mentioned, Jon, it's because we're learning more and more about how infectious diseases cause things that previously people thought were due to some other source. That includes cancers, that includes heart attacks, that includes multiple sclerosis, and now it also includes dementia as well. So there's a reason for you viewers and listeners out there to be coming to learn about bird flu. And it's not just because we're concerned about another respiratory virus causing illness, but we're also worried about all the other complications that can occur with any type of virus infecting you.
Oh, super interesting. And I feel better now, even for getting the shingles vaccine than I did before.
Well, I can tell you that the second dose doesn't make you feel better, but hopefully it'll make you feel better for the future. And so, and that's an interesting segue into, the first topic I wanted to talk about bird flu, which is risk assessments. So, how do we assess the risk of all of these new strains of bird flu that we're detecting on farms and in some, farm workers? And the US CDC just published on May 2nd assessments for two more different virus strains. One is the H5N1 avian influenza clade 2.344b, and looking at different genotypes that are occurring in there. And they noted that the risk is moderate, which they say is similar to what is posed by other recent viruses of the same clade. One of the viral strains is B13.13 from California, and that's similar to those that are currently circulating in U.S. dairy cattle, and it seems to be causing a number of sort of sporadic human infections. And the other was the D1.1 genotype virus that resembles one that's circulating primarily in wild birds and poultry. So that's a lot of codes and a lot of letters and number combinations. So Jon, let's start with first of all, a few basics here. What is an influenza risk assessment, and what is CDC looking at when it's doing these risk assessments?
So it's great, Jay. And there's a lot of things we can unpack here, I think, because it does get complicated. Number one, flu viruses are of concern because they spread so easily. They're respiratory viruses. And for those of them that spread easily among humans, they have the ability to cause big outbreaks, even global pandemics. And we've seen some of the most devastating pandemics in history caused by flu viruses. So it's a category of viruses we pay careful attention to. And because of technology and our ability now to pretty quickly genetically sequence isolates of different flu viruses, samples of flu viruses we get from people or animals, we're able to place those sequences on a family tree of influenza viruses. And that's where we get this idea of clade and genotype. We look at the entire genetic sequence and we can see things about it that tell us, number one, what type of species does this flu tend to infect? Is it an avian flu? Is it a mammalian flu? Is it a human flu? And we can look at specific markers on the genome that give us an idea of how transmissible it might be, how easy it is to jump from one species to another. And some of these genetic pieces of information factor into a risk assessment that tell us how worried we should be about these viruses spreading easily among people and causing big outbreaks. And what's been of particular concern is with H5N1. That's a type of flu virus that, traditionally is historically an avian influenza virus. Now we see it circulating in cattle and wild mammals. This is one we've always paid attention to because historically, although it's pretty rare, when it jumps from birds into people, it can cause pretty serious disease and it can be fatal in many cases. It just doesn't happen that often. What we're watching for is to see what genetic changes are occurring within H5N1 strains to suggest that they might be better at jumping into people and then spreading among people. So what we don't want to see is H5N1, which can cause severe disease, being easily spread among people. And that's the big concern about it having pandemic potential.
Yeah.
Go ahead, Jay.
Keep going. Yeah. So, I mean, this is it. I mean, a lot of people don't realize that, the diseases that cause severe illness, they worry us. But the diseases that jump easily from one person to the other, even if the illness is milder, that is the most worrisome of all, right? How transmissible a disease actually worries us sometimes a lot more than how fatal it is.
That's right. And a good example is we go back to SARS versus COVID. The original SARS also caused a pandemic and it caused a way higher fatality rate. Almost 10% of the people who got infected with SARS back in 2003 globally died, 10% case fatality rate. The difference was it was less transmissible. You didn't get asymptomatic transmission. You could isolate cases. You could control spread more easily. And so the pandemic was more easily contained. COVID, only about a 1% case fatality rate, but very transmissible with lots of asymptomatic transmission, impossible to control. So transmissibility is an important feature of different viral infections that tell us about risk. And so that gets back to this risk assessment tool where this is a gathering of experts on influenza viruses, and it is their expert opinion when looking at features like transmissibility, genetic strain, the disease it does cause when it gets into people, how many instances we see of H5N1 and each strain actually getting from animals into people. And then they make an informed assessment as to how much future risk there is, how much concern there is for a particular strain to cause an epidemic in the future.
Yeah, and then severity, of course, is one of the important factors here. And so, what do you think about sort of the data that we have on this strain circulating in poultry and this strain circulating in cows, and how that relates to the combination of transmissibility and severity? Like, what are some of the issues that are kind of being weeded out here?
Right, and so we are seeing and whether something is of concern is a relative question, but I'll now speak, from my opinion, what is of concern is we are seeing widespread transmission among cows on different dairy farms and occasional infection of people who have exposure to cows. And that is one strain. And so far, the disease is relatively mild when it gets into people. But just remember, this is a dynamic process, and influenza viruses are very adaptable. That means they mutate, they change, they have the ability to swap genes with other flu viruses if you get two different strains infecting one animal or a person. And so they do change, which is why we track the genetics in the first place. The other strain, the D1.1 genotype that tends to circulate more in wild birds and get into poultry, that has also caused human infections. So about half the US cases right now that we're tracking came from exposure to infected poultry on farms. And that strain has tended to be associated with slightly more severe disease in people. And so what we have to really think about when we see these assessments is that although the public health risk is currently low, if we're thinking forward and we're worried about the more transmission there is among cows, into wildlife, among birds, and into people, the more opportunity there is for these viruses to adapt and evolve and become more transmissible. So we can't wait until the assessment is that the public health risk is high. We need to limit transmission now so it never gets to that point. So I don't want us to get a false sense of security saying public health risk is still low, which technically it may be at the moment. We have to look forward and say, let's never get to a point where the public health risk becomes moderate or even severe.
Yeah, and I think one of the dilemmas that we face is that, these viruses are constantly evolving, and we don't want to naturally infect, we want to even experimentally infect humans to keep testing how transmissible they are. So it leads me really into, a nice segue into our second topic of discussion was, a new laboratory study that was done. Because we're not going to experimentally infect lots of humans with this, we can experimentally infect animals that might have some similarities to humans, like pigs. And this strain that we just discussed that's circulating in cattle, the B3.13 genotype, there has been a study that was done actually by the US NIH researchers where they experimentally infected 8 pigs. And so, Jon, what are some of the things, what are the reasons we do these experiments in pigs, and what are some of the things that they found?
Yeah, what's really important in our ability to use animal models, and pigs in particular, is that pigs in many ways are very similar, in fact, most similar to humans physiologically. We have a lot of the same systems, we operate the same way, and sometimes infectious diseases work similarly in pigs as they do in people. And pigs have long been considered a mixing vessel, what we call a mixing vessel for influenza viruses, because they are susceptible both to mammalian influenza viruses and also avian influenza viruses. And what we have seen historically with flu viruses is that when pigs get infected with multiple strains of viruses, we see genetic reassortment. That means that the influenza viruses, when they infect the same cell within a pig, swap genes and create new strains of influenza viruses. So pigs are particularly good at doing that, at getting infected, and when multiple strains are there, allowing for new strains to be created. And so looking at transmission in pigs is important. Pigs are also on farms, on the same farms often as cattle and poultry. And so there's a high risk of exposure among pigs to different influenza viruses, particularly if a farm has avian flu circulating in cattle and in poultry. And then what we saw with this experiment you mentioned is that when pigs are infected by this particular strain of H5N1, they got limited infection. So they weren't systemically infected. It was mostly in their respiratory tract, but they were able to transmit H5N1 to other pigs that were uninfected in the same pen. So that allows us, that demonstrates with evidence that pigs can indeed transmit H5N1 should they get infected. And that's something we can think about when we're trying to control infection on farms.
Yeah, absolutely. I mean, obviously, we want to be able to control this transmission in farms. We want to keep the animals healthy because that's just the right humane thing to do. We also want to keep them healthy because a lot of them being raised for food, and it's economically important and important to our health and nutrition. And then, of course, the last is the danger to us for if these viruses spread on these farms where you have this mixing of different viral strains inside pigs. Where it then leads to a swine flu that started as a bird flu and became a bovine flu, then became the swine flu, right?
I know it's complicated, but I think the bottom line is in public health, you want to stay one step ahead of the viruses, and that's really hard to do. But if you already know that there are certain animals that create risk of allowing that virus to evolve, you want to pay close attention to them. And so it's more important than ever that we empower and resource USDA and the CDC and public health authorities to be paying attention and tracking viruses on farms before these viruses get into people.
Yeah, and this whole concept of staying one step ahead is really important, and it's a great phrase that you just used there, Jon, because one of the ways that we stay one step ahead is by developing vaccines. And in the situation when we're worried about pandemics, developing the vaccine before the disease has become a big human problem, right? Normally, we've always developed vaccines because the disease was spreading through our communities, whether it was, polio or measles, or looking back hundreds of years to smallpox. And so we saw there was a problem, and then we did something to stop humans from getting sick. One of the ways we stay ahead of pandemic virus is develop a vaccine before we even know we need to use it. Mm-hmm. And I think you and I have been discussing a little bit offline about some of the concern we have about some of the decisions being made by this administration to essentially stop development of or funding and support for some vaccine technologies like mRNA vaccines, and only allow research into other forms of vaccine technology. And I think both you and I think that's really wrong-headed, because we kind of need to keep all options on the table. But Jon, why don't you give us a little background a bit about what this decision is and what some of your concerns are?
Well, it's simply a decision that favors an older technology of vaccine production versus something that was really promising that came to the fore during COVID, and that's mRNA vaccines. And it's not to say that other types of vaccines don't work, but we really need to, I think, move towards optimizing our strategy to develop new vaccines quickly, because we're being faced with more and more emerging viruses and viral outbreaks. So what's on the table is more resources, and in fact, most of our resources being put into developing vaccines in a more traditional way. These are attenuated viruses. So these are viruses that are weakened, that are put into vaccines that still elicit a strong immune response. And it's an old technology that we know a lot about. And the government is diverting resources away from further study and development of mRNA vaccines, which was much more of a, swap in a specific viral protein or component of the virus into a backbone or structure that signals your cells to produce that protein and also trigger an immune response. This is what the COVID vaccines were based on. And what's really powerful about this platform, and by the way, it's not a new platform. We've known about it for decades in research labs. It only became really produced for COVID, but it's a very safe and easy way to modify the vaccine to face different viruses, pretty simply, more of a plug and play thing. And so we should be investing in this technology at the same time so that we continue to learn about it, continue to track people who are vaccinated with mRNA vaccines, particularly if there's a concern that we don't have enough long-term data of mRNA vaccines in people. Well, the way to get long-term data is to support studies and continue to research these vaccines. So I think here the concern for me is really, forsaking that whole category of vaccines and diverting resources away to an older technology that, has shown to take much longer to develop, isn't as good in an emergency situation. And so that's a bit of a worry.
Yeah. And I think the real, unusual situation here, what just seems so particularly shocking, is the fact that, under the first Trump administration, they actually chose the right approach to COVID vaccines, which is they funded every type of platform that was potentially promising, whether it was a protein vaccine, whether it was a vaccine that was using an adenovirus vector vaccine, whether you're using mRNA technology. And so that is the right approach. We don't know for any new pathogen what the best vaccine technology is to be. So there is no reason to take some off the table. It's like you're going into a war and you suddenly decided that we're only going to use, bayonets and muskets instead of machine guns or drones or some other technology. We kind of need all the weapons to be researched. And then we find particularly promisingly good ones like mRNA vaccines, which are particularly good, not so much because they're more effective, but they're so good because they're just so easy to develop rapidly, in the context of an outbreak. It just seems incredibly wrong-headed to be choosing technologies because of really conspiracy theories about mRNA somehow being a dangerous vaccine technology.
And I think there's a misconception, Jay, about safety testing. These vaccines are thoroughly safety tested, mRNA vaccines included, But what often happens is when you have a proven technology and you iterate on it, you then generate the next generation of vaccine based on that technology. People think like, well, you should go back and do the safety testing again rather than build on it. But it's just not needed when you already have data to support safety of a platform. And so you're really just, iterating on that. And it's not that every time you create a new generation, you got to go back to the drawing board in terms of safety testing. And that could even be unethical to do when you already know something is safe and effective. To then go back and take time and spend resources to reprove that doesn't make sense.
No, absolutely. And there's a very common conspiracy theory out there that somehow vaccines for completely new vaccines against diseases for which you never had vaccines before, are somehow never placebo tested. When in fact, we know the COVID vaccines and all other vaccines before them, when they were introduced for the first time, when there was no prior COVID vaccine before, they were tested against a placebo. All the big vaccine trials that led to the FDA emergency use authorization, placebo versus vaccine. The same is true for previous generations of vaccines. But as you point out, once we have a safe and effective vaccine, and we are trying to develop a safer, more effective vaccine, it is unethical in science. And every ethics person you could talk to and every lawyer you could talk to in the US or globally will say, you do not then test against placebo. You test against what the standard is. So new influenza vaccines, we're trying to see, are they safer and more effective than the existing ones? So you compare them to the existing ones. So I think, this is a topic that isn't exactly, a moment-to-moment bird flu topic, but broader issues of vaccine policy are going to be a major issue if and when H5N1 becomes a human pandemic, because as you have pointed out, Jon, we need to always be staying one step ahead.
That's right. And importantly, vaccination, we tend to focus on human vaccination, but we also have the same considerations for animals. And we need to think about vaccine policies for poultry and cattle. And it gets complicated, and we don't have to get into it today, but there are trade implications in terms of vaccinated livestock. Will other countries accept animals that have been vaccinated against the disease versus those that that haven't been and are shown to be free of it? And we can talk about that more, but it's hard when you're a farmer trying to decide what's right, for your livelihood. And, there's health and economic considerations. So I do sympathize with this, but again, in the vein of being ahead of the virus, we want to make sure we're protecting livestock health, which also protects human health as well.
Great. Well, thank you very much. For viewers out there, one of the ways that you can also stay one step ahead is staying tuned to this channel, to Thermometer. We're going to keep giving you updates on infectious diseases and public health, particularly about H5N1, bird flu. And so if you like what you're hearing, please hit the like button, hit subscribe, and stay tuned for future episodes of Inside Bird Flu.
Take care. Be well.